I want to split this video up into two parts. The first part, we just watch October. And the second part, we do the math problem. All right, it's not actually true, but we are splitting it up into two parts. We'll introduce the material, and then we're going to do some more practice in the next video. So absolute value inequalities are basically solving absolute value equations, okay? And then we just plug in a couple points to see which parts of the interval we use. Because if you remember, right, absolute value functions, they look like V's. So if we're looking at when something is this equation smaller than 5, we can just find when it equals 5 and then decide, well, do we need to be inside the V or outside the V? And that's kind of true for any function, right? Maybe we had this function. When is this function smaller than -6? We'll just find when it equals -6 and decide to be smaller. Do we have to be on the inside or on the outside? And that's how we can solve absolute value inequalities. So let's get into it. We don't even need the graph. We're going to use some points, do a couple test points to figure out which way it is, or use what we know about their graphs. So first, we're going to solve the equation. What are all the points that are within a distance of 4 from 5? I spoiled it. We already did this, right? If we think about this one in terms of distance, we already answered it. Translating back from that earlier video, absolute value or a distance. This is all the points that are a distance of 4 from the point 5, or within that distance. But here's how we can solve it. First, solve the equation part. Let's find this part. When are they equal to 4? Well, that's going to be when the inside is equal to 4, or when the inside is -4. Solving both of those, we'll get that this works when x is either equal to 9 or 1. And now we just ask ourselves, are we between 1 and 9, or are we outside 9 and 1? Just like this. Are we inside the interval between these 2 points or outside the interval? So one way that you can do it is make some test points, right? Let's look. 1 is here, 9 is here. Nope. Nice try. So we can just look, which one is which? So let's pick any point in the interval. Well, you could pick 3. You could pick any point in this part of the interval, maybe 0. Any point in this part of the interval, and let's just find out whether are we bigger than 4 or less than 4. So if we plug in 3, right, that gives us absolute value of 3 minus 5, less than or equal to 4. Or how does that compare to 4? Well, that's absolute value of -2. That's +2. Oh, okay, so that is less than or equal to 4. That's great. Right? It's less than or equal to 4. And that immediately tells us our answer because we know absolute values look like V's. That means we have to be inside the interval. If you really wanted to double check your answer, you can make sure that it doesn't hold true for the outside. If we plug in 0, right, we get the absolute value of -5. That's +5. +5 is not smaller than 4, right? Not smaller than 4. So this part of the interval is not okay. And you could do the same thing and find that this part of the interval is not okay. So we have to be on the inside of the interval, between 1 and 9. Okay. Which is the same answer that we got before. That's our answer. And we can plug in some points. Any point in this interval should work out. We're curious about all the points where x minus 5 looks like a V. Where is that less than or equal to 4? Well, we found that it's equal at an input of 1 and 9. So we can see here visually that, yeah, the absolute value, the V is going to be smaller than the line between. We got more practice. One more here, and then 2 more in the next video. Given this function, g of y, maybe y is year. Y can be input. Why not? Why not? I need the soundboard with the laugh track. Given the function, Ooh, this function's a little messier. When is this function negative? So we're really asking, right? When is negative a half times the absolute value of 4y minus 5 plus 3? When is this strictly negative? Well, we're going to answer that by first finding when is it equal to 0. So let's solve that part. We need to isolate that absolute value, get the absolute value by itself. So we'll subtract 3 from both sides, get negative 1/2 times the absolute value of 4y minus 5. When is that equal to negative 3? Multiply both sides by negative 2. And when we multiply both sides by negative 2, what we get is absolute value of 4y minus 5 equals positive 6. It's good that the right side's positive. If the right side were negative 6, we'd say, oh, this never happens. And then we'd have a weird situation. We'll cross that bridge when we come to it. I think we come to it in the next video. So this is going to be true when the inside is positive 6, but also if the inside were negative 6, it would still be true. We can quickly solve these. We have a lot of practice solving linear qualities now. 4y is also going to be negative 1. Y is going to be negative 1/4. So both of these numbers should make the function equal to 0. These are the horizontal intercepts. This is when the function value is 0. And we're curious, well, do we have to be on the inside of this interval or the outside of this interval? And there's two ways of doing it. One way is the way that we did before. All right, let's look at a number line. Negative 1/4 is here. 11/4 is here. Let's pick something between them. Maybe 0. And if 0 checks out, we know we're in that part, inside these two places. If 0 doesn't give us what we want, we must be on the outside. Or absolute value functions look like V's. This absolute value has a negative in front. That negative in front means that this V is an upside down V. So if we're curious about when it's going to be negative, do you think we're going to be inside these 2 points or outside these 2 points? I think outside. Let's see what happens. Let's test. When we plug in 0, what does this function value look like? We get negative 1/2 times 4 times 0. That's going to be negative 1/2 times 5. Negative 5/2, negative 2.5. We're positive. Did we want to be positive? No, we wanted to be negative. We're not negative in this interval, which means we're going to be positive in the outside intervals. You could also like do another test point over here. You could do a test point over here and double check. Yeah, we have to be outside these intervals. On the number line, right? Outside these intervals, what is that going to look like? That means to the left of here or to the right of here. That first interval, we can be as small as we want, up to negative 1/4. We're not including negative 1/4. We don't want it to be equal 0. The right interval, we can start at 11/4, which is 2.75. And we can get as big as we want. We can be on either piece, so we'll connect it with the union sign. Good review here on interval notation. Lots going on with this problem, which is why we've got a whole nother video for extra practice on the same topics with some even squirrelier problems. So enjoy and let me know if you have questions.